Hello and welcome to the first video covering my 2022 coaster project. This first video will keep track of how I'm going to manage this project. Obviously there's a lot of parts, there's a ton of different assemblies going on in the final product of this design, so I have to start from the beginning in managing all those different parts to make it easier for myself later on down the line. And to do that, I'm using this Excel sheet. I saw an example of this a while ago when watching the Wintergatan series. If you haven't heard of that, I highly recommend checking it out on YouTube. It covers how one maker designed a musical marble machine. I won't go too much in detail. You can check that out on your own. But I used a very similar system. So in this initial page, it mainly gives me a summary of all the different parts. It'll tell me the total amount as well as the status of all the different parts together. So as you can see, the majority of my project still needs to be started. But I have gotten most of the way through designing the train as well as receiving some of the hardware that I ordered, which would be the screws in the design. I also have it split up by assembly. You can see the numbers up at the top. I will get into that in a bit. But based on each different sub-assembly, I can narrow it down to which parts need to be started and the status of those sub-assemblies just individually rather than the project as a whole. I'm also trying to keep track of this week to week. So you can see that I will just copy the current week, paste it over, and sort of explain in a short summary the problems and different solutions that I had during that week. So for one of these weeks, I wanted to try and make it more visible for riders, and because of that, the seats, it's going to be hard to see on this camera, but the seats are actually offset, so the seats in the front are placed more tightly. They're going to be more toward the inside of the train, as well as lower than the seats in the back. The back are going to be wider apart, and they're going to be higher up. This is a type of design that I've seen in the industry with Intamin trains, and I wanted to try and mimic that in this design, and that's what I tried to explain here. But this just gives me a summary. The way I keep track of the actual parts is through this other part of the project. This keeps track of individual parts. You can see I've split it up based on sub-assembly. So all of the black rows, those will highlight the main title of the assembly. And then all of the gray rows will highlight the lower assemblies. So the ones that make up the sub-assemblies. So for the train itself, it was given the number 100. That just identifies the assembly number. And then if you go further into the train assembly, you'll have the bogie assembly or the seat assembly or the zero car assembly. So those I identify by using 110 for the bogies. So that shows the first digit shows that it's part of the coaster train assembly since it has the 1, and then because it has another 1, it shows that it's still within that first assembly, but now it's given a distinction to show that this is within that other one. Within each of those parts, within each of those sub-assemblies, I have different parts. So the first 3 numbers of every item number is going to identify the assembly that it's in, and then the second 3 numbers are going to identify which part it is. I have it filtered right now just so I hide all of the placeholders. This is going to be once I get into the track, but I have those just so the main summary is not wildly off. Because if I didn't have those in place, then it would say that because all I've been working on so far is the train, it would register as a higher number completed. So I just have those as a placeholder, but for now I will filter them out. Then the way that Excel keeps track of all this is going to be through all these to the right. This is kind of going into the nitty gritty of it all. It's not really necessary for the actual management, but if I want to have the summary, it's very important to have. So this kind of covers what assembly number is it in. It shows the part count, so how many parts are within that assembly. Then it'll show the part level and assembly level. This is how I keep track of what subassembly it's part of, because one subassembly, like the coaster train, can have a lot of different assemblies within it, like the bogies, seats, and zero car, like I mentioned. So this keeps track of that. So in this case, the coaster train would be a level 2 assembly, or level, what would it be? It would be level 1 assembly, because it only has one digit in the assembly identifier. Then the bogies, because it has 110 as the assembly number, that's going to be level 2. So that level 2 essentially just means that it's within a higher assembly. If it has, let's say, the bogie requires another assembly within that, that would be 111 or 112, however many I have. It would go to a level 3 assembly, meaning that those parts are required for the level 2 assembly to be completed. All of the level 2 assemblies are required for the level 1 to be completed. And that's essentially how I'm keeping track of this. All of these on the right are just to refer to in the main summary page. That'll take place down here. So all of this, it's just for the Excel to understand it. And then I have some other pages. I'll get into this later, but through CAD, I was able to find the limits of how far my train can rotate. And this is how I calculate that. Because I plan on using Force Vector Design, a program that I'm using is FVD++, the way that you design it is only through degrees per second instead of an actual radius of a curve. And because I calculated my coaster in terms of a radius limitation, I needed a way to calculate that. And the way that I'm doing that is through speed. So to find the degrees per meter, or to find the radius, you need to first find the degrees per meter. And you need both the speed and the degrees per second. So let's say my train was running at 20 meters per second. I can calculate that, and the Excel document will automatically calculate the radius in terms of millimeters, because that's the scale that I'm working with on this. If I type in speed, it'll automatically give me the radius at different degrees per second. That way, when designing the coaster, when designing the layout, when I do that, I can do that very easily. I can just refer to this and see, if my coaster is going 5 miles per hour, so the limit of how much I can rotate is probably somewhere between 46 and 48 degrees per second. So this is just making it very easy later on, so I don't have to do all of the tedious calculations. Same with the scale calculator, because I want to keep this at a relatively low size limit. Even at this size, a coaster can very easily take up like half a room. So I want to be able to keep track of the scale in that way. So by calculating this, I found that the initial layout that I wanted to go with is going to be somewhere around 6 meters long, and that's just way too big. So I'm going to have to go back to the drawing board on that. And then I have notes. This is just the bogie, so just one of these assemblies on its own, not the full train, but just the part holding the wheels together. That's the limitations on how much the car can rotate. Obviously, I'm never going to reach that limit. Those are pretty tight radius, but I just have this notes page that I can refer to and write certain notes down if I need to refer to them later, or if I believe I may need to keep track of it. So this is essentially the entire document. As I go through the project, I have been adding different parts. So if I go back here, you can see throughout the weeks, the part count down here has gradually increased. I wanted to be able to set this up so that at any time I can refer to it, I can see what needs to be done. Through this page, I can keep track of what's been designed. I can keep track of how long it took. With most of the 3D parts, the cost doesn't really matter, but especially with some of the hardware like the screws, I want to keep track of how much this costs. So I have the cost for each part. I have the quantity. Frozen just means that it's on hold. So with the wheels, I haven't really worked on those yet, especially since the track is still up in the air right now. I may go with a 4mm rail diameter. I may go with lower. So the wheels kind of determine how the track works and vice versa. So a lot of it right now is put on hold until I continue the design. I also have it to keep track of importance. So usually something that's high importance, that's something that I want to work on right now. That's something that I need to work on first before I start working on some of the other assemblies. Something that I haven't started working on right now is the track, like I mentioned. Right now that's just unknown importance because I need to get the layout designed first, and then I can export the tracks and start 3D modeling them. And then I also have comments, which is very similar to what I have over here, but it's easier to keep track of individual parts over here. And design parts or type, that's just going to identify what type of part it is. So like here we have the hardware. I do have a hardware identifier down here. However, because these are specially designed hardware, I sort of separated them from the rest. It'll also identify what's an assembly. No limits layout. It's not really a designed part, but because it has a bit of artistry and some vagueness as to its design, I just labeled it as a creative design element. I can also keep track of status. As a part goes through different levels of status, it will have different colors to identify it. So designed is going to be orange. The orange mainly just stands out to show that it can be manufactured. Once it's manufactured, it's ready for assembly. So that turns pink, another bright color, so it's easy to identify. Assembly in progress. Anything that is currently in works will be blue. And then completed, obviously, it'll turn the whole line green. So then it will take those data, read which items are at what status, and then this part of the Excel document will keep track of that. It will list how many parts need to be started. It will list the total number of parts. It will list the individual assemblies, like I said before. And my hope for all this is that going forward, it'll be much, much easier to keep track of this. With some of my other projects, I got so lost in all the different models, so I couldn't keep track of how many different parts I needed. I couldn't keep track of which parts were for what prototype. So I kind of just mismatched everything. That's not my goal for this project. I want to eliminate that entirely. So by setting this up from the start, I can keep track of everything. I can see what needs to be done. I can see how much progress I've made. I have the total cost to see total cost. It's how much I paid for it. But it's just a way to manage everything at the same time as documenting it. And that's really what I wanted this project to be. I went in with this explicit goal to document it and to be able to actually properly manage it, unlike some of my other projects. So I hope you enjoyed this video. I know this is very unprofessional. I will put a copy of this into the description, so if you would like to look at it in your own time, you can. And you can modify it as well to whatever project you have. If you have a specific project that you want to start up that has a ton of parts, I highly recommend this. It's helped me greatly. So yeah, if you enjoyed this, make sure to leave a like, I guess, and keep following this project. The next video, I hope to cover some of the CAD modeling and some of the design that went into the current model that I have. And thank you for watching.